Nothing, it appears. Ah, Mitch wants to know what my background is. Isn't it patently obvious? It's like a little green dog dude riding a pig. It is, it's grr. And if you've not seen Invader Zim, that could keep you busy for a few hours when you're stuck at home. Morning McCullers. So this show is from when I was your age, so it's quite old, but it probably doesn't. It's pretty 90s, but it's pretty fun. I can highly recommend Invader Zim. All right, for some reason I can't see the proper chat. Ah, now we're moving. We'll give them a few more minutes for people to come in. All right, let's wait to see if that comes up. What's this updog thing? More assignment questions after the forums. We've got YouTube up yet? Doesn't look like it. We did. Most people are watching on Twitch, but some are watching on YouTube, so we'll make sure that keeps going. Still nothing, Sylvia? Okay. Well, let's begin then, shall we? Just get my second chat thingy up and running. Okay, today we're going to talk about loops. But what about loops? Well, there's lots to talk about with loops. So remember that we've already got a bunch of stuff on the online textbooks. I don't really want to repeat that, right? So the videos from coding training from Daniel Schiffman are very good at introducing loops and the syntax of loops and all that stuff with loops. You don't mean to do that again. That won't provide you any extra value. But one angle that they don't talk about, and that I think is a decent place to start, so is what we're going to do today, is to think about how loops can be learned from conditions. I've got a little ghetto document camera set up here. I'm going to see if I can make that work at some point so that I can draw things for you, because I don't have any pen-based devices on in my house. We're a bit behind the times here. So I might see if I can get that up now. And that should sit in the side of my screen, and everything will go a bit funny at first. Ah, it went away. Oh, that's not what we wanted. Okay, so that's not going to fly. I have to find another way to do that. We'll do it the super ghetto way, which means the other cable. Okay. Oh, now you get to see what music I have on my iTunes collection, which I haven't used in a long time. Ariana Grande is not mine, I promise. But the rest is. Don't. I don't need any of this stuff. Don't encrypt, whatever. This is what I wanted. Double ghetto, which means I had a better solution, but it just crashed on me. So we'll try this. Yeah. So it's just sharing my iPhone screen. That's the edge of my desk. And so you can still see the camera controls. I had a better thing set up, but that just crashed. So we're stuck with using the one with the camera controls. But at least I can draw stuff. Go away. Go away, go away, go away. Close. Quit. Oh, who uses iTunes anymore? Don't. Okay. All right. If statements, conditions. We already spoke about them, right? So those are situations where, well, in normal code, we know that when we've got a void setup and a void draw, that execution goes from top to bottom on setup, then goes top to bottom on draw, and then repeats this one over and over again. Top to bottom on draw, top to bottom on draw. Yep, simple enough. But once we introduce a condition, there might be more than one path wherever we've put the condition. So let's assume we've got a condition in the draw. Our path looks like this each time. Oh, there's two possibilities now. And they normally come back and finish up with one possibility. And then the next time draw runs, the exact same thing happens with the two possibilities, right? Now we pop. So we've got more than one path, and the setup runs once and the draw runs over and over again. That's all good. Oh, yeah, you can see my last picture too. That was a picture of a tree in North Epping. Super exciting. Last time I left the house, a long time ago. So that allows the draw to do different things on different times that it runs. The first time it runs, maybe we end up following this path and one thing happens. And maybe the next time it follows this path and something different happens. Then back, maybe we're running this path again. So we've been using that for some tricks like changing the direction of things. You can even change the speed of things, but we've put a little condition up here that tells us which of these branches are we going to go down on this particular call to draw. And we can even do that in setup if we need to. Setup can have multiple branches, but we haven't done that all that much. Okay, so what a loop is really the exact same thing, except that back here, when these two branches came back together, they're guaranteed just to continue on down the path. So there was really two branches, we tried one of them and then on we went, nothing else. But with a loop, then we have the same kind of thing. Let's just assume we don't have anything interesting happening in the setup, so it still runs top to bottom once. But with the draw, what can happen is you end up with two paths, kind of. I'm going to put dots there because it's not quite two paths. But when it gets back to the point where it's going, all right, I've done those two paths, what should I do now? It heads straight back up to the top and checks again to see which path it should follow again. So it just goes around and around, constantly doing one of the two paths you give it. Now I'll put a dotted line here because in fact with a loop, the second path is always nothing. It's exactly the same as if we did an if statement that didn't have an else. And you can see why, because if there were two paths and just constantly choosing between two paths, we'd never get out of this loop. But what a loop does is it sets up a path that you might go down, or you might just jump straight out of the loop and keep going. There's two choices every time. But it does go round and round checking those choices every time. So if you imagine you had some version of an if statement, which we do, that went down a path maybe or maybe did nothing. We have one of those. That's the if Boolean, and then we don't put an else after it. Then a loop looks like this. It's just that when it gets down to here, it goes back and checks the Boolean again and continues this process as long as that Boolean comes up true. Just continues going round and round as long as the Boolean is true. So that in particular is what we call a while loop. And you'll see it's got the exact same syntax as an if with no else. Oops. Exact same syntax as an if with no else. It's got a keyword while, then a Boolean in some brackets, then curly braces, then whatever you want to do, then the end of the curly braces. So the flow on this one is come down the rest of the code. When you get to here, check this Boolean. If the Boolean is true, then do these. Then go straight back up to here and run that process again. Check the Boolean. Is it true? Then go down. Run up, check the Boolean. Is it true? And as soon as you hit Boolean of false, my phone seems to have decided to stop for whatever reason. As soon as you hit the Boolean of false, we jump out of that loop and back down to here to keep going. As if we went past, just like with an if statement, as if we went past it and didn't find an else. Okay, having a little bit of trouble keeping up with any comments that might be coming up, so I'll get Cecilia to pass on basically any she thinks are interesting, because I don't have the chat window in front of me. And I might ignore them, I might answer them, we'll see. All right, so there you go, that's good. Let's do a little example that might show that off. What I'm going to do is I want to write a program that doesn't draw anything on the screen, unless the mouse has gone past, let's say, I don't know, let's just do width divided by 6 or something. So while the mouse is on this side of that vertical line, I want to do absolutely nothing. And as soon as the mouse jumps over to this side of the line, I want to draw a building in here, you know, like the way kids might draw buildings, just a rectangle pointing up into the sky. That's a task we know how to do, right? That's a task that we know has 2 branches. It has a branch for the draw where we're doing absolutely nothing, and it has another branch where we're drawing a rectangle. So we just need to put those 2 branches in, and the condition that tells us which of those branches we're following has something to do with whether the x position of the mouse is less than width on 6. So if it's less than width on 6, do nothing, which means that if it's greater than or equal to width on 6, then do something. And please stop asking about the assignment. We've got the forums for that. We've got to keep this, I'd like to keep this focused on this stuff. All right, so again, I got my standard size, and we've got to pick a big size because I'm on my higher screen. Oh no, I don't actually, because this computer does the doubling for me. And let's make it a nighttime. Woo. And what color are the buildings going to be? I guess they're a kind of grey. Let's go with a lighter 170. Okay, so we need 2 paths on what it's going to draw. On one path it draws nothing, which happens when width is less, mouse x is less than width on 6. But if mouse x, which is always a variable that's kept updated, ever goes over width divided by 6, then we want to follow the other path, which is to draw the rectangle. And the rectangle here that I drew on my little screen went from 0 on the x, and you know, I picked just some number up here. Don't know what it was, but let's say height divided by 2. And it went, well, I guess it went width divided by 6 across, and height divided by 2 down. And then I said, if that condition is not true, just don't do anything. So there's no else needed. I mean, I could put in else blank, but that's a waste of time that nobody really wants to do. Okay. Let's run it, see what happens. There we go, nothing's happening. My background calls no, oh, I did background 170. I'm getting what I wanted, but the colors are a bit funny. You can see it's exactly what I wanted. Two different things being drawn. So let me fix up those. And we'll have a no stroke as well. Okay. Hello, you're the fast computer. We broke you. Ah, we really broke it. Processing completely died. Come on back. All right, we got it back. Okay, now I've got what I was hoping for. I'm just going to make one change to this right now, which is that I'm going to get it to pick a random height for that building so that it's not always the same height. Oh no, I can't do that, can I? I've got to set the height. If I pick a random height, I somehow have to remember what the random height is, and I don't want to do that. All right, well, let's just stick with it as it is, but I'll put the stroke back in so that we can see the different buildings as they come up. So we didn't see a difference there because the border is just black, but you're about to see a difference. So what I want to do with this is change the program so that instead of just drawing one building, as the mouse, well, let's just not even think about the mouse anymore. How about I just draw buildings all the way across? Instead of just drawing a building, I'm just going to keep drawing buildings from left to right. And I'm going to draw 1, 2, 3, 4, well, it'll be 6 in this case. I haven't quite drawn that right. We lost the camera again. Go. And that's where we want to use a loop. We want to use a loop because we're not doing just one. Well, sorry, this looks like now I've gone back to one path on my program because always I just want to draw 6 buildings. But if I tried to do that, I would end up doing something kind of ugly, like just go back to one path, so I get rid of this, and I would end up repeating these lines 6 times. And all I'd be doing was changing some of these numbers here on the x position, right? This one wouldn't start at height divided by 2, it would start at 2 times height divided by, no, sorry, over here on the x. This one would start at width divided by 6. This one would start at 2 star width divided by 6. This one would start at 3 star width divided by 6. This one would start at 4 star width divided by 6. So that's 5, I need one more. 5 star width divided by 6. So that's okay, we're back to one path, which means there's just one path through the thing and it's going to give us what we want. Yep, there's my 6 buildings. With some reason I've got a thicker line in the middle, but that's probably just some aliasing or something. All right, so we're done. Why was I even talking about loops? Well, I was talking about loops because we've just written the same line of code basically 6 times over. And that's a real pain. If I decided I wanted these buildings to be a little bit taller, I'd have to go in and change all of these numbers. That one's got to change to that, and then that one's got to change to that, and then I've got to do that for all of them. And as programmers, we hate repeated code. Repeated code is a source of bugs. And we have a better alternative. Loops. So what a loop will do is it will, well, I told you what the loop would do. Can you see how we can use that here? Well, maybe we could run this line and then we could set up some Boolean that was going to be true exactly 5 times so that we could just go round and round and run the line 5 times. Now if we did that, we'd get the rectangles all exactly on top of each other, but I'll start with that to show you how that works. We're going to put a fill in of I'm going to make the opacity 0.3 so that we only see a kind of, it's a see-through color. I'm going to go back to drawing one, and when I draw one, it's a very light gray, no, super light gray. Maybe it's too light. Oh my lord, thank you News app. Oh no, because that's on 255, sorry, not 0 to 1. So I wanted something like 100. Yeah, it's not as grey as I was hoping. Or is that 0 to 100? Someone look up the reference and tell me. Ah, so it's going darker because it's on a black background. All right, that's fine. I should switch to a white background. That makes opacity work better. There we go. There's a very light grey. Okay, so we've got one rectangle being drawn a very light grey, and if I just repeat the line afterwards, the exact same line, I'll get a more filled in one because there's actually 2 rectangles being drawn on top of each other. So what I want to show you is a loop that goes round 5 times. So loops look like this, always. But you've got to put a Boolean expression in here just like you did for conditions. Yeah, sorry about the buzzing. So just like you had to for conditions. So what might I put in here that's going to be true 5 times and then false after that? The easiest thing is actually just to control the variable myself using... So if I set up a variable that starts at 0 and I make sure that every time I go around the loop I increase that x by 1, then I can put a Boolean in here that will come out true 6 times, sorry, and then false after that. That's what this is. It's a Boolean that's just true when it's 0, and then true when it's 1, and then true when it's 2, and then true when it's 3, true when it's 4. I need to go 6. True when it's 5, and then done. So that's much darker now because it's drawn 5 on top of each other. But 5 on top of each other aren't so useful to us. We wanted them all to be next to each other. We can get that by, well, we can get that in lots of ways, but a useful way here is we've got this cool variable x, which the first time around we ran the loop was set to 0, and then the next time round it became 1, and then the next time round it became 2. Which means if we use it inside the body of this while loop, it will cause the thing we're drawing to be different each time. Just like when we were drawing using variables before, that if a variable changes underneath you, then the thing you're doing, even if you're on one path, changes as well. So if the variable here, x, is changing as we go around this loop, we can use it. And what I'm going to use it here is to say, well, I'd like you to start at width divided by 6, but not always width divided by 6, width divided by 6 multiplied by whatever the value of x is now. First time around x will be 0, so that comes out to be 0, and then x will be 1, so that comes out to width divided by 6, then x is, and so on and so forth. So now we get our buildings being drawn 6 along in a row. Yeah? And the very cool thing about this is that there's a single number in this program that's controlling exactly how many are being drawn. It's that number 6. So if I adjust that in a couple of places, I've got to adjust it in 3 places here to something much bigger, then I can run the program again and just get a much more complicated one that would have been very hard to write myself because I would have had to do 16 different lines. And let's go really crazy And now I've got a version that I would have had to write 160 different lines to do. So even though this program is not dynamic, it's always drawing the exact same thing, it's still using a more complicated control flow, because this doesn't just go top to bottom. The control flow for this one, if I get my camera to fire up again, yes, we see. The control flow for this one looks like, well, the setup just does nothing interesting. Well, it does interesting things, but it just goes top to bottom. But the void draw goes, so I'll just put the lines in here so we can see what I'm talking about at each line. 5, 6, 7, 8, 9, 10, 11, 12, 13 is the, yeah, that's that one, 14, 15. They won't rewrite each line, but it goes 5 just runs top to bottom, 6 just runs top to bottom, 7 just runs top to bottom, 8 just runs top to bottom and makes a brand new variable in memory, right? At that point, cool. So if there's any interesting questions, pass them on, Cecilia. I'm not watching the chat, unless I've lost Cecilia, which I might have. So we get to line 8. No, line 8 still runs. Line 9 is the one that creates the new variable. Now line 10, we've hit this control flow and something interesting is happening. One of the conditions gets checked. And if the condition comes up true, we just keep going. Down to line 11, down to line 12, down to line 13. And as soon as we hit line 13, we go back up to here. And we do the same thing again. Check the condition is true. Go line 13. So what happens when the condition is false? We just skip the whole thing and go down and run these lines down here. Okay. So let's trace this one out step by step to see what happens on each line of the program. Like I said, this sets up background, fill, stroke, not so interesting, sorry, the other way around. Then line 9 sets up this new variable x and puts the value 0 in it. So there's a question there about should you know how to create these control flow diagrams. They can be extremely useful for you in understanding your own code. But as you can imagine, we aren't able to write exam questions with these because we don't have an easy way for you to draw them out. Okay. If you have any connection issues, I will note that the Friday night one, when we had lots of connection issues, recorded quite well on YouTube. I didn't see many issues on YouTube. So at the very least, we can expect we'll be able to go back and see anything. Let's trace this, keep tracing this one by one. So the first time I got down on my very first frame, because all this is happening on the very first frame, and in fact all this is happening on every frame, the x got set to 0 and put in this variable. Now the Boolean I had in here was x less than 160, yeah? So well, let's go back to a simpler one. I'm going to make a really small one so that we can check it more easily. This one just draws 2. Otherwise we'll be tracing all day. There we go. So first time we get to here, we've got is x less than 2. Well, yes, we look up x as a variable and 0 is definitely less than 2. So we go on the true side, and the true side says, please draw me a rectangle. So it does. That's the screen up there. It draws a rectangle there. Good. And then line 12 changes x to x plus 1. So it goes looking in x, gets what the value is, and updates it to 1. Now I told you that when you get to the bottom of a while loop, you jump straight back around and check the condition again. So that's what we do here. We run this exact same condition again. X is less than 2. Well, it was true before. It's just going to be true again now, right? Well, no, because the value of x has changed. So we re-look it up again and find out that it's 1, and yes, 1 is less than 2. So we do follow down the true side and run those two lines again. Rectangle and x plus 1. But this time, rectangle is not being drawn from 0 across. It's being drawn from width divided by 2 across, because the number here in the x is not a 0 anymore, it's a 1. So we draw this rectangle. So we've drawn that rectangle, and the next line sets x up to another, sends x up once more. So x goes to 2. Excuse me, should have got my eraser out so I could have used my better. X goes to 2 on line 12, and then we hit line 13. And what does line 13 tell us? Well, at the end of a while loop, so we're always jumping back around. Now, that means we check the condition yet again. This time, we're already true twice, we're probably true again, but we're not, because the x has changed underneath us. 2 is not less than 2. 2 is equal to 2. So this one fails. And when it fails, that means we jump, oops. When it fails, that means we jump right out of the loop and start running from line 14 down. And line 14 down has nothing else in it, so we're done. So that's the path on a single run of draw. And then that draw is still done over and over and over and over and over and over again, but just looks like the same thing because it always runs the exact same. Why does it always run the exact same? Why doesn't it just draw the first two and then stop drawing after that? Well, because the next time we run through draw from top to bottom, we get to line 9 and x goes back to 0. Into x is 0. Starts all over again, and the whole draw does the same thing as it did before all over again. Okay. So if you've got any questions on that one, let me know. But I'd like you to see that this is quite a lot like an if statement. Different keyword there, but everything else looks the same. And then the behavior is different, of course. Now, we do sometimes have these inside if statements, or sometimes we even connect this variable to some other variable. And if we do that, we can get different things to occur on the screen. I'm going to show you an example of that. What I'm going to do here is I'm going to connect this. So remember that when this number changed, it was changing the number of buildings that were being drawn in that space. So I'm going to make a dynamic version of this just so you can see that it can be really useful. Can you slow down a while loop? No. So it's worth mentioning that from top to bottom of draw always happens exactly, back on the frame rates, always happens exactly as fast as your computer can do it. Your computer always goes exactly as fast as it can. We just got some ability to control the frame rate in processing because processing lets us control how often the draw algorithm is run. How big is this gap between draw algorithms? But your computer always runs as fast as it possibly can from top to bottom. Well, there's lots of difference between a while loop and an if statement that we just went through. So I'll be a bit more specific and I'll see what I can get to. But the main thing is that the if just does that branch once and then moves on. The loop goes back around trying them over and over again until it fails. Okay, so I was going to give you a version of this where we don't always use the number 2. We're going to use some other number that changes while the program runs. So what other numbers do I know that change while the program runs? Well, a useful one is mouse. I'm going to use mouse X here. Now, I already know that if I use mouse X here, it's going to do something shonky. So it's going to do something insane. So instead, I'm going to introduce a whole new variable that's just so that I've got the extra space to put it, which is set to mouse X, but not exactly mouse X. It's going to be set to mouse X divided by 10. So that'll get as high as 80. That's good. So when this variable Y now, when the mouse is on the left-hand side of the screen, it'll equal 0. When the mouse is all the way over to the right-hand screen, it'll equal 80. And in between, it will be whatever it is in between. So that's a variable that's going to change as the program goes. And what I'm going to do is use that variable here. Remember that these were the numbers I was changing to change the way the, shouldn't use Y. I'll use W. These were the numbers I was changing to change the way that the picture drew. Just these ones. So hopefully when I run this one now, nothing gets drawn here because the mouse is off the left. And then as the mouse starts to move across the right, more and more of those are being drawn, because when the mouse is over here on the left, W is equal to, say, 2. And the loop's only going around 2 times. But when the mouse is over here on the right, W is equal to 80 maybe, or 79. And so the loop is going around a lot more times and I'm getting a lot more drawn. So now we can see that this loop, it went round twice on my initial version, so that every version of draw drew exactly the same thing. But this can change as well, the number of times it goes around the loop, so that by the time my mouse was all the way over the right and we were running in the 6,000th draw algorithm or whatever, this was actually running around 80 times or 79 times. Okay, so that's a reason why you would have to use loops. You couldn't possibly do this without loops, right? You couldn't have a version where, you know, it was if the mouse is to the left, draw 3. If the mouse is a bit more to the right, draw 4. If the mouse, no, that's never going to fly, because you can just have reams and reams and reams and reams and reams and reams. Why is the variable being set in the draw instead of in the setup as we're used to? That's a good question. The answer is you can put variables wherever you want. And in this case, I wanted those variables to restart every time the draw function ran. So I at least had to set them there. I at least had to have an x equals 0 to reset it at the start of the draw function, and a w equals mouse/10 to reset it. And I don't need to use them anywhere else in my program. So if I don't need to use them anywhere else, I can just declare them exactly where they're needed. That's a topic called scope we'll go into a bit more later. But either would have worked as long as you're still adjusting them. So I can put it back to the version we might be more familiar with. And then I can't have the second declaration down here, so that goes away. And that still does the same thing. Okay, I kind of like that program. What I wanted to do was make it random height buildings, but I realized to remember the random heights, I need to use another topic, which we haven't got to yet. Okay, so that's tracing. We have a trick for tracing loops that I'm going to put up a video on the textbook, but I'll give you a quick preview of it now. It's called the logic table, and it's a really useful way to keep track of what's going on in a loop. So let's go back to the old version where we didn't use the W, and this was always 2, and this was 2. So I did that trace for you using the diagram here. I went top to bottom and showed you, I've got to work out this, yes. Okay, I showed you the trace of this this way, and that's a bit laborious, especially as we get to more and more versions of X up here. We can't just keep scribbling out and drawing over, scribbling out and drawing over. An alternative is to do a table that helps us keep track. Once we realize the loop's going around more than once, we would say to ourselves, look, a table is a good way to keep track of things that go more than once. So I'll make a table that shows me what all the values of X are, and that'll help me work out whether the Boolean comes up true or not, and how many times the Boolean comes up true or not. And so the first time through the loop, this X is 0, and that one comes out to be true, so we definitely run the loop. But then X goes up by 1 as on line 16, right? So the next time we run through the loop, X is 1. The Boolean's still true, so we still run. But then the next time through the loop, because line 16's been run, the Boolean's gone to 2. That one comes out as false, and we don't run the loop anymore. We're finished. So we'll be calling this a logic table. It's not really logic. except in this sense. But it's a table tracing the execution of the loop. And as your loops get more complicated, tracing them like this is going to be very useful. Sometimes you use this technique even if you're tracing a loop that goes 1,000 times, and you'll just trace the first 5 or 6 and it'll show you a pattern that'll help you understand exactly what it's doing. Okay. Next thing to show you is the for loop. So the while loop is an easy jump from an if statement. It's very much like an if statement, but nobody really uses while loops very much. Because this pattern that you see here, where I initialize my variable and then I check the condition in a Boolean and then I increment it at the end, is so exceedingly common that we have a shorthand notation for it. And that shorthand notation is the for loop. I'm going to use I here. I'm just using another variable. You put those 3 important things all next to each other. So the 3 things that are always there, the initialize the thing to 0, the check the thing against something, and then the make the thing go up by 1 happens there, there, and there. And then the body is just the one thing you actually care about doing. And so these 2 forms that you're looking at here are exactly equivalent to each other. They do the exact same thing. But you'll see this one written far more often, and you'll get far more used to using that one as well through practice. But you really do need to think of it that as the equivalent of this. When I'm looking at a for loop, I'm thinking to myself, there's an initialization step of I equals 0. Then every time I go around, I'm checking I against 2. And then at the end of every time I go around, I'm making I go up by 1. In my head, I've converted it to this to help me understand it. And I encourage you guys to do the same. But there'll be plenty of opportunities for you to practice with these for loops. Not a problem. I just wanted to... what did I want to do? I want to start with whiles because I think that's an easier jump. Remember what we've learned about learning is that we always build our new knowledge from old knowledge. So the path, I think, to best understanding loops is to take your knowledge of ifs and translate that into knowledge of whiles, and practice with whiles for a little while. Then take your knowledge of whiles and translate that into knowledge of fors, and then practice with fors for a while, and then you might never use a while loop again, except in the one exam question where we ask you about them. Okay, so is the textbook in the stream is from the resources on iLearn? Yes. The textbook is the online textbook that we link to all through iLearn. And then the for loops are in the online textbook. They sure are, just follow the link. There's all the videos up there and it's just all there. Okay, and we're going to add a bit more to show you how to trace these using the tables. This one here. Show you a few more complicated examples using the tables. And I'll follow that up with this next thing I'm going to show you, which is using the debugger as well. So the tables are great when you can trace out most of the steps and you need to go into all of it one by one. But just like before, with variables, sometimes your program has been running for 10 seconds before you want to find out what's going on. And you can't trace that far in your head, so the debugger can be useful to help. So I just wanted to show you what the debugger shows you while you're running a loop. So we'll get rid of this one. And turn on the debugger, and I'm going to put a breakpoint right here and then go into step mode. So hopefully that'll stop when it gets to the background call. It does. So you can see my X and Y, W are set up. They've got values 0. I didn't set them to 0, but those are the default values if you recall. And I'm just going to step one at a time now. So I step past the background call and nothing happens to my variables. I step past the fill, I step past the stroke, I step past the X equals 0. That does do something, but I don't really see it. Then I go into the while X less than 2. And this is where it's checking that condition for me. And maybe following the true path, and maybe jumping down the false path. So what's it going to do? Well, it stepped straight in. It stepped straight in because it was true. That was what I hoped. It hasn't shown me anything about the fact that it's true. I had to work it out. I can see that x is 0 here and I know x is less than 2. Then it steps then, and then steps again on the x plus 1. So now I'm expecting x to go up by 1. And look where it jumps back to. Just like I did in my diagram, it jumps back up to the check on the condition. Again, it's going to do that check and decide on the true or false branch, and we've got to work that out for ourselves, but we can follow. It's obviously chosen the true branch because it's gone in and done another rect. X has now gone up to 2. At this point, we're expecting it to not go back in. So what happens when we step? That's exactly what happens. It jumps right down to the bottom of the while loop, and we're done. So that's another reason that these logic tables can be so helpful for tracing, is because you can look and at each step work out for yourself what you think the Boolean is going to come out as. And the debugger doesn't show you that because the debugger just shows you the values in your variables. Okay, that was everything I wanted to say. Does anyone have questions that I might be able to answer before we head off? I haven't quite been able to get the comments up for the YouTube people, so I haven't been seeing any of those. Okay. Does it use a case where function? No. There's no such thing as a case where that I understand. To get the debugger to work, remember you've got to turn on the debugger with this little button here, and you've got to turn on a breakpoint as well by clicking on the edge to make it stop at some part. Does processing ever do, look, don't use do while. So there are lots and lots of different types of loops around in lots of different languages. The while loop here checks the condition and goes in. The for loop does exactly the same thing, just a different form. But other languages do have forms of loops called untils or do whiles or unlesses, or don't stress or think about any of them. They'll hurt your brain too much. The whole world is settled on using just whiles and fors, and those other ones are just like old styles that nobody really cares about anymore. Okay, so just a reminder before I go about how this fits into the actual textbook. This material is all related to the online text, the software technology online text, where all of your material is now. If you're doing Comp 1000, then your lecture material is that text and the videos that are in there. Then you're going to see more videos appearing from the unit staff. These are more interactive, more off the cuff, more just kind of demonstration videos that accompany that textbook. I'm just saying things that appear in that textbook. Okay, to give you more variety, to give you more options about how you learn, so that the people who aren't comfortable learning just by staring at pre-recorded videos have somewhere to go for a more interactive experience. That's here. Okay, well, if that's that, I might disappear. Do you know of anything else, Cecilia, before I disappear? Okay, well, thank you, everybody. And they're probably going to be about an hour now. And I should say there won't be another one on Friday. The Friday didn't work super well, and I can cover enough in just an hour here once we add it into the videos. All right, thanks for coming along, and I'll see you next week.